again, I do not need the actual worksheet unless you have some type of work or solutions on it. I'm going to go over number 15. And then if there are any others, we can go over them as well. But the directions for the group with 15 wanted you to find the C value that makes the expression a perfect square trinomial. And then it says write the expression as a square of a binomial, which means we're trying to factor it into that quantity square. Number 15 is different from the previous two problems because it has a 9 in front. So we have this 9x squared minus 12x and then plus c. So we can't follow the typical rules to factor that we could use in 11 and 13 where we take the middle number and divide it by 2 and then square it because of the 9 being a coefficient number. So this is more of a logical think about it problem than it is of using like a process or a method. So does anybody know what the C value should be and why? Not because it says so on the answer sheet. No. Why? Okay, so the pattern of a trinomial being a perfect square, and he's, I think, using this pattern here. So this is the formula that we talked about when we were factoring. So the first term is squared. The middle term is supposed to be 2 times a times b. And then the last term is also supposed to be something squared. So this is the pattern for a perfect square trinomial. The first term is squared, the last term is squared. The middle term is supposed to be 2 times a times b. So, Nick, let's go back. You said that the a term is, what did you tell me that the square root of 9 was? 3. So my a term, a squared is 9. This is just not wanting to write, of course. So frustrating. Good morning. Thanks, bud.
What's up, Ryan?
Say hi to everyone.
Yes, hi.
Yeah, you want to say hi too?
What's up, Scotty?
Thanks, guys.
See you, Brian. See you later.
Oh, they will. Don't worry. Anybody else need a stapler? Thank you. All right. So looking at that first term, currently it's a squared term because it's a 9. And I know that the square root of 9 is 3. And then, Nick, you said that if you take 12 and you divide it by 2, that gives you 6. So he's saying if you take 12 and divide it by 2, that gives you 6. So that takes away this 2 part. So if A is 3, and I need these two values to multiply to be 6, then, Nick, your B term has to be 2. So this is following the pattern, not really following any specific method or process. So the middle number is a 12. That middle number is supposed to be 2 times AB. Well, to get 12 to be in the middle number, I need to take 2 times 3 times 2 because that makes 12. The 3 is the square root of the 9. So that means this number back here has to be 2 squared, which is how I get a 4 back here. Peter.
I did it a different way.
Sure.
I got the right answer.
How'd you think about it?
Start off, I took out the 3 from the equation, and then in parentheses, I had 3x squared minus 4x plus c over 3.
Okay.
And then I took negative 4 over 2 squared to get a positive, or
Now that works.
yeah.
So you took this divided by 2 squared, right?
Yeah.
And that gives you 4, and then when you plug 4 in and redistribute,
So would that work on every
yeah,
problem?
that'll work too.
Okay.
Yeah, redistribute it through. So you like pulled out a 3, but then you redistributed it back through. That works as well. Yeah, that would be a different way to think about it. And then it would give you that +4 as well. Nice job. Any other questions on the homework that you wanted to ask about? Number 7.
It's so cold outside.
I know, it was 68 degrees yesterday.
It was like warm.
It was crazy warm. Yeah. Last night it was really windy. Alright, so the directions for 1 through 9 odd want you to solve the equation by finding square roots. So if I'm finding square roots, this first part is a perfect square trinomial. This is in that pattern that I can factor in. So I have x squared, which is a perfect square. In the back we have 1/9, which also is a perfect square. Jack, how would you factor that?
Wait, I thought it was 9/16.
Number 7?
Yeah, it's in x squared.
2/3 x plus 1/9 equals 1. So how would that factor? How would the 1/9 factor, Chris?
X minus 1/3.
And how did you get 1/3?
Well, you square root 1, it turns out to be 1.
And then if you square root 9, it turns out to be 3. Yeah, the minus sign is because the minus sign is in the middle. So the first group of problems are all factorable. And you're factoring them using this trinomial pattern. So a squared minus 2ab plus b squared. That means the first number is a perfect square and the last number, even though it's a fraction, it's still a perfect square. Because if I look at them individually and take the square root, I can take the square root of 1 and take the square root of 9. That's how you get the 1/3 in there. So then to solve it, it said solve using square roots. I take the square root of each side. What is the square root of 1? 1. But don't forget that plus or minus. And the plus or minus goes here, right after you take the square root. Not in the answer. So the plus or minus goes right after you take the square root. So my problem would say x minus 1 is 1/3, and x minus 1/3 is 1, and x minus 1/3 is -1. So again, once you take the square root, that's where your plus or minus goes. So this is 4/3, and if I add, this is -2/3. So adding a third, adding a third. That's a good question too. So nobody else needs a stapler. Michael. Yeah. Michael, does the base, is it x plus 2? Yeah. And the area is 20? Yes? Do I have it right? Trying to go from memory here. Good. So this problem wants you to find the area or the value of x when we know the area of a triangle is 20. Michael, we know that the area of a triangle is equal to? Yeah, so 1/2 base times height. So if I plug the information in, just like we did before, 20 is equal to 1/2, and then the base is x plus 2. The height is also 1/2 x. So 1/2 base times height. So if I look at the two fractions here, 1/2 times 1/2 makes 1/4. So multiplying 1/2 times the half for the height. Just multiplying the two halves together. They're both fractions. They're right next to each other. They're being multiplied. And I get a 4. So now I have 1/4 x times x plus 2. There's an evil fraction in here, but you can get rid of that really quickly, Chris. How could you get rid of it? Multiply it by 4. So don't distribute it through, but instead get rid of it. So if I multiply both sides by 4, I eliminate this fraction, and now it's gone. I have an 80 on the other side, and what I have left over here on the right would be x squared and 2x. And then I can complete this square. So fraction is eliminated by multiplying by the 4, multiplying by the reciprocal. So if I'm multiplying by 1/4, I can multiply by a 4 to get rid of it. And then to use completing the square, my b value is 2. I'm dividing that by 2 and squaring it. What is 2 divided by 2 squared? 1. So don't forget to add the 1 to both sides. Got to keep the equation equivalent. So I have 81. And on this side, the square root of 1 is 1, so I would have x plus 1 squared. And then taking the square root, I end up with x plus 1. Don't forget the plus or minus. Plus or minus 9. So x plus 1 is equal to positive 9 and negative 9. But I know my answer has to be positive, so the negative 10 option would not work. So if you could make sure your name is on your homework. Pass that forward, please. We have one final method to talk about with solving for x squared. And it still is going to have square roots in the answers. So we'll still be working with square roots. But we won't necessarily be taking the square root. The square root's already going to kind of be embedded in the problem. So it is section 4.8. And again, this ends the solving portion of the chapter. So this is the last part of the solving. So sections 4.3 through 4.8 have all been solving. And then we're going to kind of backtrack and go back to the beginning of the chapter, and we're going to use the solving to help us graph. So kind of wrapping up the solving part here. 4 different ways to solve equations when we have x squared. Factoring, using square roots, completing the square, which eventually does use square roots. And then the last option is called the quadratic formula. This is a formula to solve a quadratic equation. It literally is a formula. In science, there are a lot of formulas that you will use. In chemistry, in physics, even in general science, there's various formulas that you use. In math, we also have formulas. So a formula literally is something that you take and you plug things in. So think of even geometry, all the formulas in geometry for all the area and the volume of all of those wonderful geometrical shapes. So the quadratic formula is a way that we can solve a quadratic equation. This works for any quadratic equation, where factoring only works for a specific kind, or the completing the square only works for a specific type. It has to be perfect squares. Using a square root has to be in a certain format, whereas the quadratic formula works for all of them. So this is like, I can use this method for any type of problem that has an x squared, if I want to. The other thing that we have here is this word discriminant. The discriminant is a little piece of the quadratic formula, and it tells us how many solutions a quadratic equation has. So the discriminant tells the number of solutions, or remember, a solution is an answer. So my answer, my quadratic equation, does it have one answer? Does it have two? Are they real? Are they imaginary? That's what the discriminant will tell us. So it's going to be a number that we're going to calculate, and then by using this number, I could say I have two answers that are real, I have two answers that are imaginary, or maybe I just have one answer. So there are a couple of different options. So underneath, we have a little space here for the quadratic formula, and we are working with this equation, ax squared plus bx plus c, which is really the equation that we've been working with pretty much all chapter, ax squared plus bx plus c. The solutions of the quadratic equation. So an equation is different from a formula. An equation you're solving for. The formula we're using to solve. So I'm finding x, because that's what we're solving for, negative b, and then a plus or minus, because there's a square root in here. And anytime I have a square root to solve, I have a plus or minus. And then b squared minus 4 times a times c, and then divided by 2a. Chris, I'm going to pick on you because you had Mr. Warnock last year.
Yeah, you made me sing that dumb song.
Yeah, that dumb song. Well, I don't have the cute little jack-in-the-box that he has. Thank God. But I do have a cute little song. And if you hear the song, it gets in your head, right, Chris? Yeah. So if my technology works. He's cute.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Sadie really liked this one the best,
X is equal
so
to
that's why I
negative
chose
b
this one.
plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square
Better than
root
Mr.
of
Warnock?
b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Should I play it again?
Yeah.
Yeah?
That last bit sounded like a sneeze.
Yeah, play it again. So we make sure we're, oh, this is a different one.
Let's suppose that you're writing a really important
Oh, we don't
email
want
to
to
a colleague.
suppose. Here we go. My daughter Sadie, I was listening to a couple different ones, and she liked this one the best. Ah,
How big should a drone battery be to maximize its time?
there it goes. Mr. Warnock has a jack-in-the-box that did he bring out his jack-in-the-box? You can't remember. I'll be sure to send this to you so that you can listen to it over the
X is equal
weekend
to
too.
negative b plus or minus the square root of b squared minus
Steven, like you
4ac
speak dancing,
all
right?
over 2a.
Yeah?
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
That last part sounds like it could be like Halloween music. Yeah, I could play it tomorrow night during trick-or-treating.
Sounds like a sneeze, Shanny.
Yeah? So, we are going to use this wonderful quadratic formula to help us find x in 3 problems down below. So, let's see if we can try and solve for x. You got that little tune in your head now. I have it written on the board too, and you at the top of the page. So, it says to solve an equation having 2 real solutions, and right now we have x squared plus 7x equals 6. So, the first thing we need to do is set this thing equal to 0. So if we're using the quadratic formula, just like factoring, we're going to set it equal to 0 by taking the 6 to the other side. So again, this is a method that I can use for any equation with an x squared when it's set equal to 0. The numbers in the problem represent A, B, and C. The coefficients, or the constant term at the back. A formula is plug and chug. You take numbers, you plug it in, you work your way through it. So using the formula, x is equal to negative b, my b is 7, so now it's negative 7, plus or minus the square root, b squared minus 4. That's easy. And then a is the coefficient with x squared, which is 1, and c is a negative 6. And then that last part, all over 2a. So negative b plus or minus the square root b squared minus 4ac all over 2a. Think of their little song that goes with it. So underneath, we're going to simplify this down to one number. So we have 7 squared, which is 49. And then we have negative 4 times 1 times negative 6. So this is 49 plus 24. So 7 squared is 49. Negative 4, 1, negative 6 makes 24. What is 49 and 24? Jack, what is 49 and 24? 73. If you get an answer like this, you can't factor. So this problem would not have been factorable. My answer is negative 7 plus or minus the square root of 73 divided by 2. It says I should have 2 real answers. These are real. It's not imaginary. There's not a negative underneath. There are 2 because of the plus or minus. Jack, can you break down the square root of 73? Is there a perfect square that goes into 73? No. So there is not. 73 is prime. So this is how your answer is going to look, similar to some of the answers from completing the square. So they're not always going to be nice, pretty answers. But I've solved for x. I found a solution. So we're going to use it again. If you look at the next problem, number 2 says you're going to have one answer. So one answer that's real. And we're going to try and use this quadratic formula again. So A, B, C. A, x squared, B, x, and C. So x equals negative b. B is already negative, so now it's positive. Chris, please check out your earbud. And then b squared. 4. You want to go get a drink, Maddie? Yeah. A and C. And then 2A. So Peter, 30 squared, what is 30 squared? 900. 4 times 25 times 9, negative 900. So what do we have the square root of, Peter? 0. On the bottom is 50. So we have 30 plus or minus the square root of 0, which is plus or minus nothing. So what we're left with is 30 over 50, Peter, which is really 3/5. It said I was supposed to have one real answer. I have one real answer because the plus or minus 0, I can't take plus or minus 0. Plus or minus nothing doesn't change the problem. So it's just the 3/5 my one real answer. So there's one more problem involving using this quadratic formula before we kind of look at the discriminant part. And this says that it's going to have imaginary solutions. So now my answers are going to be imaginary. We're going to have that I in it. So looking at this problem, negative x squared plus 2x equals 5. What do you think you'd do first? Alyssa, what would you do first here?
Take out
We could take out a negative. That would definitely be one thing. What do you think you'd do with that equals 5? Yeah, let's put it on the other side. And you could take out the negative if you don't like seeing it. We can keep it there. Totally up to you. We can keep it and then it's one less step, or you can get rid of it by taking it out. It's kind of your call. So I'm just going to keep it. A, B, C. So must be equal to 0. X equals negative b plus or minus the square root b squared minus 4. And then a has a negative in front because I kept a negative there. So that's a negative 1. C is also a negative. It's a negative 5. And then we're dividing by 2a, or 2 times negative 1. So just be careful with the negative. If you're keeping it in the problem, it needs to kind of follow through. So 2 squared is 4. Negative 4 times negative 1 times negative 5 is negative 20. And Brady, 4 minus 20 is
Negative 15.
negative.
Whoa, negative 16.
I figured that's what you meant. We had negative 16 there. So I have a negative 2 plus or minus the square root of negative 16, and then divided by negative 2. Chris, question?
Twos cancel out.
Okay, so that's a good part, a good question. This division sign is almost like parentheses. I have to divide last. So this gets done last. We need to simplify anything on the top. So the division bar in a fraction, anything underneath that is the last thing you do. We have to kind of work on the top part first. So the negative sign makes our imaginary number. That part comes out and gives us the imaginary number. So I have a negative 2, I have a plus or minus, I know I'm going to have an imaginary number. Ava, what are we going to have in front of that imaginary? A 4. And then we're dividing by negative 2. So the whole fraction is being divided by negative 2. Really, this means that the fraction is negative 2 divided by negative 2. And then it also means I have the 4i divided by negative 2. When you have a fraction, whatever's on the bottom affects everything on the top. So both of those values are being divided by negative 2. So Ava, negative 2 divided by negative 2 is? Negative 2 divided by negative 2? 1. And then a plus or minus. 4 divided by negative 2 is negative 2. In that negative 2 there, it doesn't actually matter because of this plus or minus sign. Because one's going to be positive or one's going to be negative no matter how you look at it. So I don't need that extra negative there. Because the plus or minus, one has to be positive, one has to be negative. So that extra negative really is kind of like arbitrary. I don't need to have an extra negative sign. So now I have 2 imaginary answers because of that I. So when you're simplifying the fraction, you simplify the denominator last. You divide last. You got to do the top part first. Questions? So on the next page, there is a little diagram at the top talking about the discriminant. The discriminant is the little part underneath the square root. So it's still a formula, but it's a little piece of the formula. So our discriminant is b squared minus 4 times a times c. That's the discriminant. So it's a little piece of the whole quadratic formula. And that discriminant gives us 3 different options, and we just solved 3 problems with those different options. If the discriminant is greater than 0, which was the first equation we solved. So the number underneath the square root, if it's bigger than 0, I have 2 real answers. This is what my graph looks like if I have 2 real answers. So if x-intercepts is what we're solving for when we're finding x, where's the graph crossing the x-axis? And if my number is bigger than 0, my discriminant, then I have it crossing the x-axis twice. The one in the middle was our second option that we just solved. And that's when it was equal to 0 because we have the square root of 900 minus 900. I have one answer because it only touches the x-axis once. And then my last option was when we would have the square root of a negative number. So we just had the square root of negative 16. It was a negative number, so therefore I have 2 imaginary solutions. So the discriminant tells us right away how many answers you should have. So that when you're kind of working through it, if it doesn't match up with your discriminant, then somewhere you made a mistake as you were working through the problem. We are going to kind of look at the discriminant in the next 3 problems. It says find the discriminant and then give the number and type of solutions for the equation. And I think you have a cute little chart. Oh, there's my cute little chart. So the discriminant part is b squared minus 4ac. And then our type of solutions, the number and type would be, are there 2 real, 2 imaginary, or 1 real? So we'll kind of look at those. So for letter A, we're going to actually find the discriminant. And it's just b squared minus 4ac. So just by calculating this piece, I know how many answers my problem should have. So Gabby, if we plug in numbers for letter A here, what numbers would we plug in for b squared minus 4ac?
We plug in 6 for B, 1 for A, and 5 for C.
Okay. And then we're going to calculate that number. So we have 36 minus 20, and Gabby, 36 minus 20 is 16. That's the value of the discriminant. It's 16. The second part says give the number and type of solutions that the equation has. 16 is bigger than 0. So how many solutions will my equation have and what would they be? 2. So Peter said 2. And specifically Peter 2. Oh, that wasn't Peter, that was Chris. Sorry, Chris. Sorry, Peter. So Chris, we have 2 solutions because it's positive and bigger than 0. What type of solutions? Are they real or imaginary? They're real. So I would have 2 real solutions. So if I look at the little chart above, if this number that I just calculated is bigger than 0, 16 is bigger than 0, I have 2 real solutions. I'm going to have 2 real answers. See if you can calculate the second discriminant. So keeping 2 pieces the same, but just changing the c value. So we still have 6 squared. We still have a minus 4 times 1, but now c is 9. So we're calculating the discriminant. Tells us how many answers we should have. So Sadie, we have 36 minus?
Negative. I guess plus 36.
Just what's 4? Yep. That's 36. And 36 minus 36 is? 0. So my discriminant is 0. How many solutions do we have? Do you know, Sadie?
1 solution.
Yeah, it's 1 real solution. And then the third option, again, keeping A and B the same, just changing the C term, 6 squared minus 4 times 1, and then times 13. So, Jack, what is 4 times 1 times 13?
52.
And 36 minus 52 is?
Negative.
Negative 16. Jack, how many answers are you going to have?
2 imaginary.
Right. So because this is negative, I have two imaginary solutions. So if you flip the page, there are 3 other examples, but I want us to look at the last one. We're going to find the discriminant, determine how many answers there are, and then I want us to actually find the solution as well. So going to the last problem, number 3. Number 3 says x squared equals 9x minus 11. What do you have to do first with the problem? Jack? Make it equal to 0. Does it matter which side is equal to 0? No. It's whatever side you want it to be equal to 0. So you could say, I like keeping x squared on the left, so I'm going to move the 9x and the 11 to the other side. So that would make it x squared minus 9x plus 11 equals 0. Or you could say, I really don't care what's positive or negative. I'm just going to move one term to the other side. But one of the sides must equal 0. So I moved both to keep x squared positive. Then I'm not dividing by a negative number. So Josh, if we plug for the discriminant part, so the first part is the discriminant. What would we plug in for the discriminant, Josh? So this gives us 81 minus, which is 37. That's the discriminant. What does that tell us, Josh? Right, 2 real solutions. So 37 means there are 2 real solutions. Now I want us to actually find them. So we're going to use the quadratic formula. It's already over on the board. Negative b, Josh, negative b would become 9. Plus or minus the square root. I already calculated the square root because I already did b squared minus 4ac. Actually, Josh did that. And that's 37. And then we're dividing by 2 times a, which would just be divided by 2 times 1. Hi. Hi. How long were you standing there?
Oh, like 2 seconds.
Okay.
Yeah.
Thanks. Oh, you know what? He's not here today.
Oh, okay.
Sorry. Thanks. See you later.
Yeah.
2 times. 2 days. I
I know what I need today.
Yeah, I see that.
Really?
Yeah, I'm not sure if he would wear that.
Yeah.
Especially not the sneakers. So 2 times 1 on the bottom would just be divided by 2. Questions? So I have a worksheet because I figured you didn't want to have book homework. And the worksheet, you're going to do 1 to 25 odd, which is, you guys make off way better than my honor train without this. They got a lot of homework this weekend. Lucky them. Yeah, so glad you're not that much. And this is on pretty blue paper. That should be good. Yeah, it's not like 23 to 123 odd. It skips around. Yeah, I don't. It's weird. I don't. It is. Feel it. It's weird paper. Make sure you're doing 1 to 25 odd. I will send the solutions through Google Classroom so that you can check those answers. You might be able to fit it on here because these problems are spaced out some. Have a fantastic 4-day weekend, Douglas.